this is a little bit of a meta talk. Yeah, so it's not about something of data science itself. It's about how can we be better humans that absorb knowledge. Yes, and the idea is when you've been in the field for a little bit, and you have also grown of a certain age, you realize that you read a lot, but you then also forget a lot. Yes, and you get to this point of like, why are you going to read something if you're going to forget it? And the key here, and this is what I'm saying, this is a meta talk, is to have metadata, yes, to keep information about what you read. So these are breadcrumbs to find it again later on. Particularly over time, the known item search, as it's called, information retrieval, has become very, very hard with web search engines. Every time you search for something you read before, you have this giant wall of spammers that hide your item. And by spammers, I also mean websites that are very, very good at SEO, and whatever keyword you throw, you end up in medium.com. So in my case, I many times don't have the slightest clue of the title or the authors or anything like that, but I do remember very strange things, like where did I read this paper? Or how I read it. I printed, I projected in a wall, I read it on the laptop, yes? I also remember how I found it and the approximate dates when I read it. And so the idea is then to have metadata to keep this type of memory hooks to help you find things later on. And this has been around for a while. So I've been trying to put together a solution that is useful for myself since 2012. And I think by now it has grown to a point that may be useful for other people. It's very, very Kierkegaard. So this is something I wrote for my own use. But I believe it can help you get started also with your own scripts. It's a series of Python scripts. And there are plenty of tools to do bibliography management, yes. One that I know is very popular is Zotero, yes. This one in particular, what it has is it asks you more information than other tools. The idea is to spend not so much time reading, but also a little more time cataloging things. And the basics is that everything goes into a data model that is just one file. It's a YAML file. And you can think of this YAML file as a bib text file plus a mind map. But the beautiful thing is that it's just a text file. You can open it in a text editor. You can carry it in your phone. You don't need to have search functionality over that file beyond what you can search on using a text editor. And this file, even though you can read a lot of notes, don't grow that big. For 500 papers I have in the tool so far, I have about 100K. And the other nice thing is something that bothers me about other solutions is that they use binary formats for storing, and if it breaks in upgrade, you're left with a binary blob that there is nothing you can do. Here, well, if the tool goes away, you still have the YAML file, and also you can commit it to version control. Together with the YAML file, if you want, the tool allows you to have a paper repository where it's a digital asset manager where you store all your PDF for you in a directory balance and use a hash-based access to it. How that helps? Well, if you download the same paper 20 times, you only keep one copy. Yes, but you don't need to use it if you want to use just the bibtext plus mind map. From that information, the tool allows you to get a static website. The idea is that you read, you upload the things, and from time to time, you generate this static website where each paper has a different page and the bibtext, etc. And again, in this page, you can use the search functionality from the browser to find what you're looking for, and the pages are linked to the actual file in your paper repository. So you have this type of notes with information about each paper. On top of that, you can import the bibtext files. You have support for reading lists. So you can say, well, I have all this paper on this topic, and I'm going to be reading them in this order. And you can define arbitrary relations between papers. You can say, oh, this paper contradicts this other, etc. So far, the only one who has an active support is the citing relation. And if you have your own papers into the tool, it can generate a bib file for you that you can use for publication. So this is a extract from the bibtext file I use in my book. And the other thing is that it can import some nodes from plain text files with custom codes. And the most interesting feature and something that can be useful from this talk beyond the tool is that it has a UI that relies heavily on custom Jupyter notebook widgets. Yes, so you can run this tool inside the Jupyter notebooks and says, I want to edit one of these entries, and it will produce this little UI with buttons where drop-down boxes and things like that. This makes heavy use of closures and can be interesting for other people looking for examples of custom Jupyter notebooks for their own work. On top of that, it also has a full text search engine. Yes. So if you register the files with the Digital Asset Manager, it runs a series of text extractors, including Word documents and PDF and HTML, and indexes them. And among the things that allow you to do a query by example. So if you're working on a paper, you can say, okay, which other papers I have in my repository that are similar to the text of this one? We actually made use of that with a paper we wrote with Annie last year. And you get all that in only 10 files. Yes, with 2,000 lines of code. So the idea is really something you can try to study, hack it, yes. As I mentioned, I make heavy use for my book. The book finally have come out. It has around 300 citations. I managed to upload around 100 into the tool. And also I would really like to thank the community from Learn Data Science for their help with the book. Several people from the community proofread the chapters and were very, very useful. So what I'm finishing now is a tool that you give a folder with PDFs, a zip file, and help you sync them. And and now it's on GitHub, so hopefully I'll get some bug reports of things that are not working. I already have an installer on test P.A.P.E.R, and that's it. Thank you very much.
Awesome, great. Sorry that I had to make the alarm go off. It was just right at the end. Okay, great. So now we have about 10 minutes for any questions. If you don't have a mic or anything like that, just throw your question in the chat, and I can go ask for you. Otherwise, just go ahead and very calmly, politely try to start asking questions. I guess I can start. I was just curious about, so it's based off of BibTeX, right? So you can actually put any kind of file, not just like a paper or a PDF or anything like that. Is that true?
So it handles BibTeX, but the artifact node is not tied to BibTeX. And also in BibTeX, you can use @MISC if you want to handle things that are not published. I use this a lot with PDFs printed from web pages, like on Stack Overflow or things like that, to keep track of those. And that's very, very useful. Although some websites these days don't allow you to print a PDF anymore. The web is getting more and more hostile.
May I would like to understand, like, what was the main feature that you saw that was lacking in tools like Mendeley or Zotero that made you write your own?
So the mind map aspect, yes, that you can have relations between the papers. So those ones just handle the BibTeX, so to speak, but not the custom metadata.
Do you have an example of the metadata that is generated through the process you run these through? Because you talked about keywords and subject matter and...
Yeah, so one of the beauties is that the type system that the system uses is you can define it yourself. So you can add any metadata you want. For example, one of the examples I add on the sample notebooks, you say I want to keep track of which lectures I use this paper in. Yeah, so then you create a type lecture where you say, well, I want to know which institution I gave the lecture and what year or things like that. And then you can associate the papers to these lectures, right? So the type of metadata that you will need depends on your own needs. The one I do track is where I found it and where I read it and when I read it. Yeah, as I mentioned, this is what helps me with my own memory hooks, but every person is different in that regard.
Can you associate, let's say, your summary of each paper that also references other papers? Is that a kind of link you can make?
You can make that link. You will have to do it by hand or program it on top. Yes, but precisely that's the type of things that you would like to have, is to say, well, this reference this or this contradict this other.
Could you show like how the mind map works? Like, I believe you're using the Jupyter.
Sure. So the mind map aspect happens by nodes of type relationship. So this is the whole type system of the tool. So you have a relation, and you have a source and a target artifact. Yeah. So let me see. I think here I have my own thing. Let me check. Yeah, full text engine. So So, for example, these are the relation between this paper that I wrote a while back, and then you have so let me make this one. So if you say edit node, so this is the relation. The relation is between this paper and all these other papers. So this is the source, and these are all the targets. Yes, and it's a citing relation. So if you want to change this relation to something else, let's say opposes, then you just change the text that opposes, and here you can add more papers or remove them from the list of targets. Yeah. So, and this list is live. You have all the things you have. That's why it took so long to render.
Understood.
Do you have plans, or do you have already a capacity to actually make a graphical mind map through those connections of all the documents that you have?
Yeah, I mean, a graphical will be pretty straightforward. The main is like would be useful for anybody, something like that. To me, for the citing, what I get is the BibTeX file. Yeah, so I keep track of as I'm reading the papers for something I'm writing. I start adding them to that citing relation, the ones I want to use.
Cool. Thanks.
And again, if the tool is not that interesting to you, you have already your workflow, that use of the Jupyter widgets it is quite interesting. You know, here you have a complex graph data model, and it's being edited and used from hooks. I'm thinking there is many things coming out now on data science that involve DAGs and stuff like that. So having a little editor for that is not a bad thing either.
I actually have a little bit more of a more general question, and that's about your book.
Mm-hmm.
about how much time do you think you spent doing the research for the book versus actually like writing it out? And how much time did you actually, I guess, how much did you plan for the research and writing phases, and how long did it actually take?
So I know those times fairly well because I didn't start writing until I have a contract signed. I felt that there are too many books already. So if I didn't have a feeling that there was interest in the book, I wasn't going to write it. So it took me between 1 to 2 years to do the background. And then the writing took, I was thinking it was going to take me 6 months, and it took me 9 months. The thing that blew out was the copy editing, because I had to go through 2 different copy editors, and it went really bad. That copy editing took almost a year. And that was quite unfortunate because the book should have come up before the pandemic. Right now is a very bad moment to come up with extra material to the market. Everybody is producing material as there is nothing to do. But all in all, my takeaway from this is book writing is fantastic. It really opens your mind, and it's a very different experience. But very few people are reading books these days. So it's a little tricky. I'm still happy it went out, but it is not what it used to be, say, 15 years ago. I think right now making a YouTube video series most probably has much more reach.
So there's probably time for 1 or 2 questions if anyone wants to get in the last couple questions. All right. Well, otherwise, let's give a muted round of applause to Pablo. So thank you for presenting, and
Thanks, Pablo.
yeah. And next up, we have Sampoorna.
Hey.
How do you want to be timed? Do you want me to do it, or would you like to just go off of like a internal?
Yeah, if you can do it, that would be great.
Okay, awesome. So here's what I will do. It's kind of like on-air production meeting. 6 means 6 minutes left. 5, 4, 3, 2, 1, and then like this will be 30, and then like I'll flash 10 if that makes sense.
Okay, sounds good. Yeah.
And I won't start until you go into your second slide, so you can go ahead and cheat on that first slide if you want to.
Okay. Okay, cool. Shall I start presenting?
Yeah.
All right. Okay, is my screen visible?
It's currently black.
Oh, okay. Hang on.
Try. Oh, no, it looks like yes.
Okay.
Yeah, we got it.
Okay, sweet. So it's oh wait, hang on. This is the one. Data in the wind industry. So it's the one you're seeing. I'm a little confused about which of my screens it's sharing.
So I can currently see a Google, what is that? A Google Present slide, and then it says data in the wind industry.
Okay. So wait, this it is the presentation mode though, right?
It doesn't look like it's in presentation mode.
Oh, okay. Okay, hang on.
No, I think it was right. I think we saw the presentation mode title slide. I think we were saying the right thing.
So
I don't know what I'm talking about.
Well,
Okay.
yeah, looks good. I think it's
okay. Okay. All right.
Sorry for sucking you out.
Sorry about that. Anyway, so I'm Sampoorna, and welcome to the talk. I'm a data engineer at P.A.P.E.R Renewables. I'm going to talk about data in the wind industry. It's going to be a bit of a general talk, just like going into the kind of data we deal with and some of the applications of that data. So P.A.P.E.R Renewables is a tech startup that builds neat data analytics tools and interfaces for the wind and solar industries. So a lot of this is just stuff that I work with every day, pretty much. All right, so start. Okay, so before we get into the data, what is a wind turbine? Really briefly, it's a giant machine that converts kinetic energy. It harnesses the power of wind and converts it to electricity. And over the years, they've been getting really big. So one of the proposed designs, the latest designs, is for this turbine that's going to be roughly the same height as that of the Eiffel Tower. And a lot of the advancement in performance of wind turbines is due to advancements in the design of the turbines, leading to a huge increase in wind energy production globally. However, another part of that is also software, which makes it easier and more efficient to work with wind farms, large wind farms especially. But then also it's possible to aggregate a large amount of data, look for trends, look for patterns, and try to reduce operational costs through software. So getting into the data and the data model, at P.A.P.E.R, when we connect to a wind farm, we get a variety of data types and from different data sources as well. So you have sensor data, time series data in either 10 minutes, which is the standard, or higher frequency data. You can get geospatial information, so like layout of the land, et cetera, contour lines, et cetera. Contract information between the manufacturer and the operators of the wind farm, meteorological data, site activity data, and also power, weather, and market forecast data. And the main thing is taking all of these different data sources and correlating these data points so that you start with 100, 500 data points, but then turn that into a few thousand different data points, doing everything from simple calculations, correcting wind speed for air density to more complicated predictive models and running algorithms that help us identify underperformance. So what are the main challenges at this stage? The first one is inconsistency because you get data in different formats and in just different data connections with each farm. And to be able to do scalable analytics, you need to be able to standardize it. The second thing is data labeling and cleaning. Everybody would know that's like a huge headache. A large part of the value add is just at this stage itself. And then finally, it's missing or incomplete data. And then once you have done all of the cleaning, labeling, validation, and I should quickly mention that the data labeling here is not in terms of supervised learning labeling, but it's really just data tagging. Okay, and once the data has been cleaned, labeled, validated, and all the pre-processing and pre-analytics are done, you can then build out the analytics. So the main areas, if you're really roughly looking at it, of underperformance would be, one would be on the storage, curtail, the grid, and the grid part of the thing. Then there is pitch and control of the turbines themselves. So are they following the direction of the wind closely or not? Or if you can tighten the controls, and maybe you get better performance. Then there is icing, forestry, geospatial, what kind of an impact the geography or the lay of the land plays on the performance of the turbines. And then finally, wake effects, so how the turbines interact among each other to impede wind and impact performance. And then the second kind of thing, apart from detecting areas of underperformance, is to do condition monitoring, which is essentially to be able to catch when something is going wrong before it actually goes wrong. So this graphic is illustrating the three main types of maintenance you can do. So you can do preventative, which is typically maintenance on a schedule. It's more costly. And there's condition-based, which is maintenance when, based on certain conditions, you detect there is a need for some action. And then there's corrective, which is after something has gone wrong. And this is an example of a gearbox being replaced. if there is some kind of a small problem within the nacelle, which is the head of the turbine, I guess, is the main part of the turbine. And if you catch that early on, and let's say it's just a small bearing or something, then a replacement of that can typically cost like $15,000 to $70,000. But if it leads to a catastrophic failure and the entire, let's say, gearbox has to be replaced, then including all the cost of bringing people in, etc., it can cost like up to $300,000 to $500,000. So there's a huge saving that you can do for for the site operators if you can catch things before they happen. So one of the ways in which we can do that is by doing peer-to-peer analysis. You can look at temperature of different components. In here, this is the nacelle temperature. And you can see if there's one turbine, in this case, turbine 10, which is acting up and it's running hotter than its peers. This is an example of the gearbox oil temperature. Also for turbine 10, you can see it's running hotter. However, because different turbines face different conditions, it's not always possible to do peer-to-peer analysis to catch all the problems accurately. So one way you want to do this is by building digital models, where you build a model of performance, of like the expected correct performance of the turbine, and then based on that, detect when something is going wrong. So there are some considerations to keep in mind when you want to build a model like that. I'm just going to quickly go over to an example where you can see really briefly that this is the trained expected behavior is the blue one, and the orange one is the observed behavior. And you can see that it's spiking, it's deviating from what you expect. So here's another example. And you can use these kind of models to detect if something's going on. And that's it. Thank you.
Right on the money. 1 second left.
Wow.
All right, open for questions. Just let me set the timer for that. I guess one of the nice things about being host is you can just ask your questions in front of everybody. So I was going to go ask, how long does a typical wind turbine usually last? And how often would you have to do preventative maintenance if you wanted to keep everything in, say, tip-top shape?
That's a great question. I do not have the numbers off the top of my head, but wind turbines typically, especially more modern versions, will last quite a few years. I think the expected, you can get all your money back in terms of building costs and everything within 2 to 5 years, I believe. And then a wind turbine can typically last up to 20 to 30 years. And there's also this concept of refurbished towers or turbines, where you can start with the skeleton of a turbine and then install parts inside it. So you can make an existing wind farm last longer, essentially, or work longer. And in terms of how often these things happen, for example, for the gearbox, which is a pretty critical part of the turbine, I think I've just seen some, they're actually, it's pretty rare that one of them will need to be replaced. And that's kind of the problem that, because if you are studying this and you want to prevent that from going wrong, you kind of also cannot wait to see when it does go wrong. So a lot of preventative maintenance is essentially it also prevents us from actually seeing how long it would have otherwise taken before it blows up or something like that. But I would say on average, maybe one per turbine might, or one in a farm might go off maybe in a few years, 3 or 5 years, something like that, in that ballpark number.
Great. I have a question from R in the chat, which is, what's the most common failures or alerts that you've seen?
I would say the one that is most actionable for clients would be yaw analytics or yaw control analytics. So that is over here where you're essentially trying to see if the turbine is tracking the wind correctly. And it's most actionable because usually there are some software parameters that you can just fine tune to make it track better. Of course, if the turbine is tracking it too closely, then the problem is it can wear out the motors. So there is a sweet spot you need to find, which is some of the analysis that we do for this. That's what kind of involves that. That's what it involves. But yeah, that would be the most actionable, I would say. Pretty common to see a lot of misaligned turbines.
I have a question around how you're managing. You kind of mentioned it, like you're producing a bunch of data or getting a bunch of data and producing a bunch of predictions about how they should do things. And then they go off and do these things, do the preventative maintenance and deal with the yaw and all this stuff. And then that produces another set of data that then is fed back into your models.
Yeah.
How are you dealing with potentially bad cycles of like data telling you, like leading you further and further down a line that's actually like a false positive? Do you know what I'm saying?
I'm not sure why it would be a false positive.
Or potential false positive, I guess, like just I'm thinking of the example from policing where crime data leads to the detection of more crime where the crime data has been before, which leads to a negative cycle of finding more crime data there. And I'm wondering if you have similar kind of concerns with this space of data.
Okay, so like for yaw analytics, for example, we do generally know what, for different models, what the curves look like how tight they usually are. So I think like you can do analysis across your fleet and see if there's outliers and try to fix those. And then usually that's what we recommend. Like you try to catch the outliers. And so you would still have like on the average would still be average essentially. So that wouldn't be affected. For the predictive models, it is a risk if you are frequently retraining the models. And yeah, that's something that we definitely have to be careful about. That's all I can say. It's a hard problem. Yeah.
Do you foresee that you will have a data drift due to climate change?
Interesting. So maybe, yeah. So the thing is, hotter air is less dense, and that means it produces less. You can produce less energy from when the weather is warmer. So we do see that this like on an annual basis. That if you, for example, if you train your data only using data from winter, then in summer your models will start firing and saying, oh, your turbines are underperforming. But really what happens is you didn't look at your data set was incomplete, your training data set. So I would imagine that over time, I'm not sure how much of an impact in terms of near term, short term, how much of an impact that would have, because we're looking at in temperature increases of on average a few degrees, and the difference between winter and summer that leads us to these kind of underperformance. This is a good 20 degrees or so. So I'm not sure in terms of the models how much of an impact that would be, but I imagine maybe over 100 years. I don't know, but yeah, it can totally have an impact.
What about destruction by forest fires and the particulates?
Yeah, probably forest fires would lead to, it'll be really hard, but you'll probably just turn the wind farms down at that time and then run for your life or something like that.
Do you need to be... Sorry, go on.
I'm wondering, you were... The visualization that you showed with all the lines of those different turbines is from a medium-sized wind farm or from a larger wind farm, and this is just partial data. How feasible is it to use this to use the P.A.R platform for smaller wind farms with let's say, less than 10 turbines. Does that make sense? Do you have any customers, or is the platform just way too expensive and only makes sense for bigger wind farms?
So we do have a bunch of small wind farms. There's, I guess peer-to-peer analysis is not very useful in that case, but there are other things. For example, I mentioned for your analytics, we can often look at the fleet or like our portfolio, essentially look at like have a model for how like a Siemens turbine is supposed to perform, and you can still provide value. Even if it's a really small farm. And then, so that's one aspect of it. The other aspect is the pricing also depends on the size of the farm, the price for the software, So we do end up having quite a few small farms as well, yeah.
Do your models like take in consideration redundancy and like the failures on the sensors itself?
Yeah, that's a great question. Definitely a very challenging one because we do have some kinds of like, logic to catch missing data or to try to automate that process of detecting missing data or faulty sensors. So for example, if you just see a sensor like flatline, that you don't expect to flatline, then that would be one way to, tell that it's not working. We do have some like preliminary filters, but I'm sure there's like lots more that one can do. Yeah.
Do you monitor vibrations or sound? I've seen some companies that actually look at accelerometers for bearing failures, and they train models on that type of data.
Yeah, that's right. There are companies that do that. We don't do that yet, but maybe in the near future.
I see.
Can I ask, what is the awesome talk, by the way? I loved it. Can I ask, what is the edge? Like, what is the stuff that's hard right now, but maybe you guys are working on versus the stuff that's completely figured out? And also, what's the line between like what's proprietary and it's like, do people publish openly about this stuff, or is this more like more proprietary stuff?
Great question. Yeah, so to answer the second part of your question first, people don't typically publish about this that much, and research that's out there is usually either simulated work or there'll be like one wind turbine, like a wind tunnel where you can control the parameters. Or even sometimes you'll have even like when people use like they say it's real world data, it's still like a really small wind farm maybe that nobody's using or is just for research purposes, so it's not being maintained so well. So a lot of this is proprietary, like the actual algorithms being used and all of that is it's not openly shared. A lot of the figures about like, for example, building a model of yaw control is also something that is not that commonly, it's not, freely shared again. The other thing is like for icing, for example, a lot of manufacturers want to sell additional icing modules. So they're like software that can be like, that you can install as part of your turbine running software that will detect icing, and that can both complicate our work for us or provide us some more interesting problems, because sometimes, so we also have our own algorithm to detect icing. So sometimes the thing is to compare it against the manufacturer's icing algorithm to see if that's working well, or if it's too sensitive or not sensitive enough. And a lot of this we have to reverse engineer because we don't actually have access to that because it's proprietary again. So in short, there's like, especially like, for example, the condition monitoring work is something that it's just, there's not that much research around how effective it really is in the real world. And a lot of the numbers you do get, they're like from simulations and stuff like that. So not sure if you can really trust it, like in the real world, how that would hold up. And then What was the first part of your question again?
It was about like what's the edge in technically, like what's currently hard or maybe coming down the pipe versus what part is just really figured out by now.
Right. I would definitely say condition monitoring is something that's still a really hard problem. One of the issues, like in general, I would say a lot of the models you need to build for wind turbines, the reason they're really hard is because you're like looking at you're studying a system that is changing over time, like it's degrading over time. And even if you have a wind farm with 100 identical turbine models, they all face, or they get to, they're like, they have different operating conditions. So there's wind coming at them from different sides. The inter-turbine interactions, which is the wake effects, like how one turbine is waking another turbine, those things, that's another factor that even just studying that, there's a lot of research, ongoing research into how you can control turbines, like to move away from one another and how that can impact, improve the performance of another turbine. And yeah, so stuff like that is really hard. And just the fact that you're collecting data as the turbine is running and also degrading over time. And you can't train a model on one turbine and then expect that to apply on all the other turbines. If you change a component, if you do any kind of system software upgrades or anything like that, then you're basically starting from scratch. You can't use the previous data anymore because now it's a new system. So yeah, I would say all of those are problems that are still to be solved.
Thank you.
Okay. So we have just 2 questions. Now I see that there are 3 questions. How about this? I'm just going to read to you the first question in the chat, and then if we have time, we'll answer the second and third. And if not, we can always talk about it afterwards. But the first question in chat is the temperature data usually enough to find the failure points, or do you have to frequently augment them with other data like geospatial data or weather data, etc.?
Good question. So temperature data by itself is just like one piece of the puzzle, I would say. A lot of times it could just be a bad sensor. So what we do is if we notice something like this, we alert the site operators, and they will then decide if they want to call in a crew to inspect the turbine or not before they commit to actually like replacing a part or something like that. So yeah, it's not at that stage where you can just look at it and know exactly what is going wrong. So in this example that I have on the screen, there's 2 different things: gearbox oil temperature and nacelle temperature, that are both hot for the same turbine. But these are both fairly, like general, because the nacelle temperature is the entire nacelle. It's this entire thing. And so you can't really tell without more inspection where exactly the problem lies.
Okay, I'm just going to sneak this last one. This is the last question. Cool. We'll ask everything else later. Can you talk about your journey to becoming a data scientist/engineer at Clear Renewables? What level of DS skills and domain knowledge is the company looking for potential candidates for DS roles? And I guess on top of that, is Clear Renewables hiring?
Yes, actually Clear is hiring. So you should go check out our website. That is clear.eco, and go to the careers page. And there are a few things, mostly software. And yeah, we're also expanding to Germany if you know someone there. Anyway, for the data science roles, we do expect, I'll just go back to the slides. We do expect a fair amount of wind background. That's why I'm a data engineer, not a data scientist. I started as a full stack developer at Clear, and pretty much was involved in everything from setting up data connections to implementing some of the algorithms to building out the front end as well. It was a team of 3 people at the time, or 3 developers and a team of 10 in all. So it was pretty small. It was back in 2018. So not that long ago, but now we're more than 65 people. So it's been quite a journey. I would just say I didn't have a lot of specific, like Win-specific background, or actually didn't have any Win-specific background at all. I had some data science background. I did my master's in computer science with the focus on recommender systems. And a little bit of that did help me with developing these algorithms, the predictive algorithms. But for the Win part, it was all that I just picked all of that up on the job.
Okay, that's awesome. I tried doing the muted hand clap. That didn't really work for me. So whoever can unmute and go do a round of applause, because this was a really great talk.
Thank you.
Thanks.
All right, and next up we have Robin.
Hi, can you guys hear me?
Yes.
Yes.
Right, I'm going to share my screen. Is that working?
Yeah, I can see your whole. Yep, everything looks good. And Robin, how do you want to do timing?
Actually, what are the options? I have a timer next to me, but what?
Well, I can. You can put on the timer, and then I will also make hand gestures to you.
Okay.
Saying
per slide?
Sorry?
Per slide or how many minutes?
For how many minutes? I'm not going to do it slide by slide.
Okay, perfect. Okay, thanks so much.
Yeah, and I don't start the timer until you get to your second slide, so go ahead and talk as much as you want here.
So yeah, as it says, I'm going to talk about TalkRL Podcast, which is interviews with researchers in reinforcement learning. And I was inspired to do this when I heard some other machine learning interviews that I felt, where I guess maybe because they were more targeted at a pop audience, they weren't very in depth, and also I felt that there wasn't much coverage of RL, of my specific subtopic that I was interested in. There wasn't that much coverage of that in the existing interviews, and at the conferences there wasn't really much time for back and forth, and so I was chatting with someone at a cafe after NeurIPS 2018, and that made me want to do this. Also seems like a way to get to know about different schools and potential grad school or PhD. Also desperation. There's just so much knowledge out there, and I was looking for another way to keep up with the field. So so far I've been very lucky to have amazing guests. I think because these people are so generous with their time, and we're just talking about their own work, which is of interest to them. So yeah, I've been lucky to be able to chat with some fascinating people, and I've learned a lot from them, and sometimes I listen to them again and learn some more. I'm just going to talk about a few of the people that I spoke to, some of their work. Natasha Jaques, Dr. Jaques was actually my first guest, and she had recently published a paper on sequential social dilemmas. These are like Prisoner's Dilemma, but temporally extended games. And her mechanism that she added to reinforcement learning agents was a social influence reward that allowed, that was an intrinsic motivation that allowed these agents to solve these group problems, which each agent acting greedily was not able to solve. Issues like similar but like analogous to like climate change or basically tragedies of the commons. So that was episode number 1. I was very lucky. She rolled the dice on a show that had no track record yet at that point. Scott Fujimoto at Mila was another guest who was kind enough to appear, and he spoke about his work. He invented the TD3 algorithm, and he did some groundbreaking work in batch or offline reinforcement learning. Specifically, he showed that existing methods didn't work very well with static data, and then he showed some solutions to that problem as well. Taylor Killian was one of my last guests. He studies machine learning for health, and he talked about a couple of his papers, including hidden parameter MDPs and, direct policy transfer for hidden parameter markup decision processes and counterfactually guided policy transfer in clinical settings. So this is using basically the idea of categorizing the environment, or I would say parameterizing the environment, variations in the environment on the left, and on the right, using causal model, counterfactual models to allow for policy transfer. So in terms of what I have taken away from being able to, thanks Matthew, for being able to chat with different people in the field so far, I think there's many variations in how different people see the field and what's important to them, issues they care about, and their perspective, and so that means that everyone has a very different. Seems to me that everyone has a very different angle to all these issues, and that's what keeps it very interesting. So I like to say that after every episode, I'm a different one of these blind people. And RL is like this elephant that I'm trying to figure out. After every episode, I'm like, oh, it's a rope. Or after the next one, I'll be like, it's a table. It's actually a table. And it's because people have such different points of view on it, which keeps it interesting to me for sure. And I'm also reminded that RL is as much of it as it's technology or approaches to solving problems or settings, it's also a community and a social network. And you can look at it. You can look at anything that way, and sometimes it's an interesting way to look at it. In terms of how I do the podcast is pretty simple. You just use Audacity, the free software, simple mics, a few tools like Clean Feed and Transistor for hosting everything. And my son is kind enough to do the audio editing lately, so that really helps. And I really want to thank our hosts, Matthew and Andrew, for setting this up, and for the organizers of this group. This group has been great and really inspiring to me. So thanks, everyone, and feel free to reach out anytime.
Awesome. Thank you.
Yes, thanks. So any questions from anyone?
Just wanted to say thanks, Robin. As a regular listener, I really enjoy your podcasts, and I just wanted to say you don't make one of the great mistakes that I see lots of podcast hosts make, which is talking too much. You ask very insightful questions, and then you keep quiet, and then you don't interrupt the guest. And I really enjoy that, because sometimes it's frustrating when the hosts keep cutting in, trying to inject their own views prematurely in the conversation, and you don't do that, and I really appreciate that. So.
Well, no one's there to hear I just trying to stay out of the way of these brilliant people. So my goal is 10 moments of them speaking for 1 moment that I speak. That's my target. Thank you, P.A.P.E.R. Thanks for your kind words. It actually means a lot to hear your encouragement.
Robin, do you record these in a studio or in a specific location, or just wherever you can meet up with the person?
Oh, I use cleanfeed.net, so we just both call into this webpage, and we just okay. I've never seen any of these people. Almost never. Well, I've met a couple of them, but so it's just in my home office. Yeah.
Okay, cool.
Which is in the woods somewhere. So that's another reason why I wanted to do this, because I'm stuck out here in the woods. I don't get to see anyone. So it's a great way to.
I have a question about the spoken aspect. There was only times where people felt that they will have to draw something to further discuss. It's fantastic. They can discuss all these topics just without any graphics, right?
Absolutely. I guess for me, the complexity of running a camera and I found the quality, I'm not really good with video. And so, yeah, I have really focused on plain audio. And once in a while, I think, damn, it would be really nice to point to something. On the other hand, I think I'm less focused on trying to explain the exact mechanics of some complicated diagram or something, and more about different types of issues that we actually can discuss, I would say.
There's a question online. How hard is it to get a new guest, and how do you approach asking them to be a guest?
Yeah, I mean, at first I thought it was impossible because the first few people I wrote to never said yes or never wrote back. So I thought it's impossible to get guests. Actually, it's just a statistical Poisson process or whatever you call it, and you're going to have some kind of hit rate. Not even percent. It's just like you're going to have. It's just a numbers game. So if people say no, just ask a little bit more, and then just keep up. You have to have some kind of rate where, like, people basically for every 3 people I ask, 1 says yes, and mostly no one says no. They just don't reply. And getting started took forever because I was waiting for this one professor to say yes, and he kept saying maybe, or yes, but not for 1 month, 2 months, 3 months. And so I wasted 6 months waiting for him. And what you have to do is just ask like 7 people, and like you'll get 2 guests right off the bat. But it's a cool medium. Yeah.
Was it Chaba that you were waiting on?
No, it was no one who's been on my show yet. It was the Van de Pan in UBC robotics. I mean, he's a great prof. He's just really busy.
So who would be your dream guest? I have a guess.
That's a really great question. I mean, I think if you asked me in the past, it would be some really big name person, and I'm trying to think of who that was. I think right now that'd probably be David Silver would be like a really big name. And I mean, I've asked him and he said yes, but he said kind of like it's postponed a couple times. And I would love, don't get me wrong, I would love to have someone like, I think he's massive, of course. On the other hand, I actually love talking with the grad students, PhD students. I think they're really cool. They all have their own perspectives, very different perspectives, and I love how basically I usually learn more from them than from the bigger name people. Although I love having both. That's kind of the point of my podcast, is that I think there's so much on it's not about how big the name is. It's like everyone just has a different perspective and something to add to it, I think.
From the chat, have you changed your ideas on RL after talking to all of your guests?
Yeah, totally. After every guest, I have a different perspective completely. And I feel like naive about when I started, I would say. I probably felt a little more I was more naive. And I kind of picked my guests. After a while, I started picking my guests based on what I wanted to know too, right? And so you can kind of like fly the plane a little bit. And then some people just come to you. That started happening too. Yeah, so I think there's podcasts on a lot of topics, but I think there's a lot of empty space, and so maybe whatever your topic is, you might find it's a useful thing for you to do, whatever your area of interest, and let me know if I can be of any help to you setting it up.
So, are you at a point where advertisers are coming to you, or?
I don't have a lot of traffic. I have had book publishers coming to me and wanting to have their book authors on the show. I've had a couple researchers want to be on, but no one's asked to pay me money. And I think the audience is small. It's specialized, but it's not large. So I think if you were going to advertise for some generic data science tool, you'd probably be better off on some high volume. Okay, so I'm in the extreme quadrant of like I don't explain anything about what RL is. And I jump right into, like, I've read the person's paper and I'm asking questions like fairly in depth about the papers. I'm not at the level of the researchers, but I'm not trying to make it very friendly for a pop audience. So that really cuts out a huge amount of people. And then of all the people who like data science, is a minority are interested in RL. So I don't think I'll make any money in advertising. Although my son keeps telling me to get a Patreon. I think I'm like, it's not worth it. I'm like $1 a month.
this is kind of a general introductory question, but so many RL algorithms are like massive. Is there any non-trivial problem that an individual like person, say, who's here, should jump on if they want to get into RL?
Sorry, a non-trivial problem?
So, like, let's say beyond like the sort of classic, I don't know, like Pac-Man or Atari games. More complicated than that, but not as complicated as, say, doing a Dota.
I mean, Atari still takes a lot of samples, right? It's easy. It's like easy in that it has a lot of progress has been made, but it's not fully solved in that they're still making agents that are making it better, and it's still not trivial. Like, it's not like a given that every time you run your algorithm, it's going to solve that Atari game, and or how long it might take. And in terms of getting into RL, I mean, there's so many different aspects to RL. I think the most straightforward place to start is with multi-arm bandits and contextual bandits, which is everywhere, and I think that probably applies to almost everyone's business in some way. So I would probably start with that.
You can like take a look at the news recommendation systems that I think Yahoo shared the data. I use it in my master's and treat it as a reinforcement learning problem. It's free.
Oh, cool.
Yeah.
And so that's a multi-step, like a full MDP formulation, and how does that work?
Oh, you just like have a vector of information of the user, and you need to decide which of the available ads, not ads, but news to show.
And is it treated as a multi-step problem or every step separately?
Like like the feedback loop is there is a new user. This is the vector of information. Give me the news.
Do you track to the next state they go, or is it just every state independently? Like is it a one-step
how I
MDP
did
or a multi-step MDP?
I extended Thompson sampling and worked from there, like with like different distributions for each of the parameters.
Cool. So as a bandit, as opposed to full RL, is that what you mean?
Yeah, I as a bandit. Yeah.
Yeah. Cool. Awesome. Yeah, I would love to hear her talk about that someday.
Okay.
Another cool area, I think you know about it, Robin. We've chatted about it, but another cool potential application of RL is in combinatorial optimization, solving integer programming problems. There's been a lot of recent advances. I don't think it's quite beating the state-of-the-art operations research algorithms, but people are trying.
That's amazing. I would never suspect that. I would always think that the classical ones would do better, but
yeah, I mean, the classical ones, there is a few steps that are done at random. So for example, in branch and bound algorithms, the branching is done at random, but for a specific problem, you could train it so that it learns where the most effective or the most useful branching and cutting would be. So you could train it beyond the generic OR algorithms that are supposed to work in any scenario. If you want to focus on a particular case, let's say traffic optimization or something like that, then there is something to be learned and potentially improved.
Sounds a little AlphaZero-ish in a way.
Yeah. I mean, yeah, that's the motivation, I guess.
I have a super general question. Start to finish, how much time do you think one episode takes?
It really depends on what kind of guest it is. If it's a guest who's coming on to share like maybe just 2 papers and they have like don't have like an epically long history, then I just literally will read their 2 papers, a few references maybe, and it's not that big a deal. So I guess most of the time is in preparation. So maybe I'd spend 5 hours in preparation for them. And then what I do is I write out talking points, like questions I have after reading their papers, and I send that to them. So getting that all in and then the editing part is like pretty quick now. In the beginning, the first 2 episodes, the audio editing I was horrible at, and it took me an entire weekend to audio edit 1 episode, and now that's down to like 1 hour and a half. So,
That's not too bad.
Yeah, no, that part's not too bad. The problem arises if I have a guest who has like a very long research history. I had that problem with Shaba and with Michael Littman. They have so many papers, and I don't know where to draw the line, and I end up reading way too much and understanding actually not that much. And I find that really, really hard. So I find it easier to really focus on a couple papers.
So we're kind of down to 1 or 2 more questions. So go ahead and shoot, and then we'll hang out. And I guess you can answer more questions if you want to, Robin. We'll work on breakout rooms if we have to.
Sure, I'd love to chat.
So what do you think is the next big breakthrough in reinforcement learning, and what problem do you think reinforcement learning is going to be disruptive coming up? What's the next big thing? Tough question.
Yeah, actually, I'm not really sure what is really the next big thing. I think that I think it's maturing at its own rate, and I think it's really hard to predict that rate, but it's definitely not fully baked right now, and it seems promising. So that's why, I mean, kind of what I'm doing is kind of like doing my best to like be part of the field and hang out in the field, so that when the wave does come, when the wave is at the right point, I'll like be there. I can paddle. But and so I'm kind of doing that, but I'm not sure what. Like, it seems like the promise is it seems very large. In principle, anything can be solved with it in a way, but in practice, that's not true at all. So when problems are going to fall to it, it's not really clear to me. But it's not magic dust, right? It's like a real thing, and it has its problems. I don't know if that helps.
Yeah.
How hard do you think the transfer learning is right now?
In RL?
Yeah.
I think it's harder and worse than in supervised. So it's not that great in supervised, maybe. So maybe even worse.
Okay.
But I mean, so I guess environments like OpenAI ProcGen, procedural generated environments from OpenAI, was designed to test that very issue, because with Atari, for example, the agent is learning in the same levels as it gets tested on, and so it can just memorize the levels, and maybe it doesn't actually understand anything at all. And so the procedurally generated environments are changing the levels every time you run it, and so it can really only perform once it's done some amount of generalization, which is sort of like a type of transfer learning in a way, right? It's related anyway.
Yeah.
But transfer is really, really hard, and I would say that's nowhere near figured out. But that's one thing that this Taylor Killian was trying to do with this counterfactual inference. He was saying if your data is from one hospital and you want your policy to run in a different hospital that has a different distribution of patients, that doesn't work unless you do some special things, and that's what he was doing with this, with adding causal models here.
Cool.
All right. That's everything. So let's go give Robin a round of applause for another really great talk. Yeah, thanks, Robin.
Thanks, Robin.